Our brains are incredible organs, constantly working to keep us alive and functioning. Like any other part of our body, the brain needs a steady supply of oxygen and nutrients delivered through our blood. But what happens to the blood after it has circulated through the brain? This is where the dural venous sinuses come in. They act as the brain's drainage system, carrying away waste products and ensuring the continuous flow of fresh blood. Imagine a busy city with a network of roads and highways. The roads represent blood vessels supplying the city with essential goods. Just like a city needs efficient waste removal, our brains rely on dural venous sinuses to remove used blood and waste. Understanding these sinuses is key to understanding the brain's overall health and function. Dural venous sinuses are a unique type of blood vessel found within our skulls. Unlike typical veins, which have a more traditional tubular structure, dural sinuses are formed by spaces between layers of the dura mater. The dura mater is a tough, protective membrane that surrounds the brain and spinal cord, acting like a natural helmet. Think of it like a sandwich. The bread slices are the layers of the dura mater, and the space in between where you'd put the filling is the dural sinus. These spaces aren't empty though. They are lined with endothelial cells, just like regular veins, and are responsible for collecting and draining blood from the brain. This blood carries away metabolic byproducts, carbon dioxide, and other waste materials that the brain needs to eliminate. Dural venous sinuses are strategically positioned within the skull, forming a complex network that effectively drains blood from all parts of the brain. They are often located where the dura mater folds in on itself, creating these unique channels. These sinuses vary in size and shape, some appearing as triangular spaces, while others are more cylindrical. One notable feature of dural sinuses is their lack of valves. Valves in regular veins prevent blood from flowing backward. However, the absence of valves in dural sinuses allows for more flexibility in blood flow, ensuring drainage in various head positions. This unique structural characteristic is essential for maintaining consistent blood flow within the brain. Blood circulating through the brain eventually needs to return to the heart and lungs for reoxygenation. This is where dural venous sinuses play a crucial role. They collect deoxygenated blood from brain tissue, along with cerebrospinal fluid, a clear fluid that surrounds the brain and spinal cord. This mixture then flows through the network of dural sinuses, moving towards the back of the head. The blood eventually drains into two large veins called the internal jugular veins, which are located on either side of the neck. From there, the blood continues its journey back to the heart. Section 5. Key players. Major dural sinuses. Several major dural venous sinuses work together to drain blood from the brain. These include the superior sagittal sinus. This large sinus runs along the top of the head, receiving blood from the upper part of the brain. The inferior sagittal sinus. Positioned below the superior sagittal sinus, this sinus collects blood from the deeper regions of the brain, the transverse sinuses. These sinuses run horizontally along the back of the head, connecting with the sigmoid sinuses. Finally, the sigmoid sinuses. Shaped like the Greek letter sigma, these sinuses carry blood down to the internal jugular veins. These major sinuses, along with several smaller ones, form an interconnected network, ensuring efficient blood drainage from all areas of the brain. Section 6. The importance of dural sinuses. Dural venous sinuses are vital for maintaining a healthy brain. Their primary function, draining blood and waste products, is critical for preventing a buildup of pressure inside the skull. This pressure regulation is essential for proper brain function. Imagine a garden hose with a kink in it. The water pressure builds up behind the kink, potentially causing damage. Similarly, if the dural sinuses are blocked or not functioning correctly, it can lead to a dangerous increase in intracranial pressure. Section 7. When things go wrong. Sinus issues. Several conditions can affect dural venous sinuses, potentially impacting brain health. Blood clots, infections, and inflammation can all disrupt normal blood flow within these sinuses. This disruption can lead to serious complications, including stroke, brain swelling, and even death. One example is a condition called cerebral venous sinus thrombosis, or CVST, where a blood clot forms in one of the dural sinuses. This blockage can prevent blood from draining properly, leading to a range of neurological problems. Section 8. Keeping your sinuses healthy. While some factors affecting dural venous sinus health are beyond our control, certain lifestyle choices can promote overall brain health and potentially reduce the risk of complications. Maintaining a healthy weight, managing stress levels, and avoiding smoking are all beneficial. Regular exercise is also crucial as it improves blood circulation throughout the body, including the brain. This improved blood flow can help maintain the health of the dural sinuses and support their critical drainage function. Section 9. Conclusion. Essential for a healthy brain. Dural venous sinuses, though often overlooked, play a crucial role in maintaining a healthy and functioning brain. They act as the brain's dedicated drainage system, ensuring the continuous removal of waste products and the delivery of fresh, oxygenated blood. Proper function of these sinuses is paramount for regulating intracranial pressure and maintaining the delicate balance within our skulls.